So this is where we're at as we're going into working with the graduated syringes. So the problem is that I really should probably use the 12 mil graduated syringe, and if I try to do that, notice it doesn't fit. I can't get it in there. So if you read the directions over top of that, where it does talk about where to measure, it says that if needed, we can use a small beaker to pour out some of the liquid to measure. So I have a small beaker here, but it also says we never want to return any solution to a stock bottle. So if I pour out all of my test tube A, then I will have nothing left in my stock test tube. All I need is 3 to 4 milliliters. So I'm just going to pour barely what I need in here and leave the rest in the test tube to serve as stock. The reason we want to do that is because if there were a contaminant in this beaker, then if I tried to pour that back, I would contaminate the stock solution for everyone who ever uses it. So we just want to pour out what we need to avoid waste and to avoid contaminating our solution. So I'm going to pull this up, and then we will get our good, accurate measurement for my first syringe. As we're doing this, we're going to be measuring to the top of the plunger, not the dome, but right here where the plunger is meeting the barrel. So we'll see I'm in between the 3 and the 4. So I'll start here, and I'll notice that this is not graduated in 1 increments. This is graduated in 0.2 increments. So I'm going to have to look at it and say, okay, 3.2, 3.4, that to me looks like it's pretty much right on the 3.6 line. And so I would be very tempted to say 3.60. But if I do 3.60, that implies that I have a line to look at to ensure that it is between 3.6 and 3.61. I can't do that. All I can say is that it's in between 3.6 and 3.8. Now this is going to go from test tube A into test tube B. So now we're going to do the same process from test tube C. We need to measure 4 to 5 milliliters. And I'm going to take my clean, dry beaker. I'm going to pour a little bit of the stock solution into the beaker so I can use it. I'm going to rinse out my syringe, and I'm going to use that syringe to measure out the 4 to 5 milliliters. I'll put that in there and pull it up till it's in between the 4 and the 5, and then we'll get our accurate measurement. Okay, so now again, we're going to be looking at where this plunger meets the barrel. So we're going to be looking right here. So we're definitely in between 4 and 5. So I'm going to take this and look at to get to where that plunger is. 4.2, 4.4, 4.6. I think it's in between 4.6 and 4.8. So now we can see the result of putting that liquid from test tube C into test tube D is we have again changed the color of our solution. And in this case, I again have a little bit of yellow in here that I'm going to need to pour out and rinse, and that little bit of yellow in the tip that I'm going to need to also rinse before I deal with what happens with test tube E. So our last measurement here is to take 4 to 5 milliliters out of test tube E. So I'm going to again take my clean, dry equipment and pour in about what we need. Trying not to put in too much extra so we don't waste a lot. Okay, so here is our measurement. Again, we're measuring to this point here. So I definitely see that's in between 4 and 5. So we're going to estimate between those lines as we need to. If it's right on the line, remember we can put point, say 8, but if you believe it's a little before or after, that could be considered 4.7, or it could be considered 4.9. So you need to find your best estimate and place it on the box for the volume exact volume removed from test tube E. Okay, so now you can see the results of all of our different transfers. And if you were doing, since you were doing this on video and I can't initial where you saved your results, what you can do to tell me that you watched this on the video is you can write my little code word in that spot where it says to initial, and my little code word is going to be rainbow. Because